So now we're going to talk about balancing equations. There's good and bad parts to balancing equations. One, if you like puzzles like Sudoku and those kind of type of thing, you're going to like balancing equations because that's very much what it's like. The bad part is I can only really teach you tips and tricks and techniques, but there is no set of steps that I can teach you that are, always the same. You always do this and then this and then this. You kind of got to get the skill, and the only way you're going to get that is by practicing. I am going to give you a few like little tips and a few little tricks and techniques that you can use, but ultimately it's going to come down to how much you practice this. So one key thing is the difference between coefficients and subscripts. Coefficients are big numbers written in front of compounds in an equation, and subscripts are small numbers written to the bottom right of compounds. Here's the difference. You can change a coefficient. You can add or delete or subtract a coefficient. But what you can't do is you can't change a subscript. So you can add as many coefficients as you need to balance the equation, but you cannot change the subscript. So what this means is this 2 with this CL here, you cannot delete that. You cannot change that little subscript. You cannot add a subscript. The only thing you can do is add big numbers in front here where these lines are. And what's going to happen is you add them, you're going to multiply through, and then things are going to become even. So the best technique that I have learned over the years is locate the arrow, because that separates reactants from products. Underneath the arrow, just write the symbols of the elements you have. So I have Zn, H, and Cl, and then make 2 lines. What's going to happen is once you write all the elements on the left side, it is automatically going to be the elements that exist on the right side. You shouldn't have something on the left that's not on the right. That doesn't exist. They may not be in the same order on the right as on the left. So make sure when you're doing your counts that I'm about to do, that you pay attention to what you're actually looking at. So when I say count, you're going to count initially how many are there. So what I see here is I just see Zn, just zinc, no subscript, no nothing else. So that means there is 1 zinc, there is 1 hydrogen, and there is 1 chlorine. So what I did is I just looked for subscripts. 1 zinc, 1 hydrogen, 1 chlorine. So that's the counts on the left side. On the right, there is 1 zinc, 2 chlorines, and 2 hydrogens. Now the goal of balancing is to make the numbers equal going horizontally. Zinc has to be the same on both sides, but it does not have to equal the H and the Cl. They only have to be the same going across like that. They do not, and most likely will not, be the same going down. The other rule is your numbers must be in the simplest format. They must be balanced. They must be simplified. So the coefficients have to be simplified. So what I'm going to do here is I'm going to start adding coefficients until all of my atoms are equal on both sides. Here's where the hard part comes in, because sometimes there's no real rhyme or reason. It could just end up being guess and check. One rule that you should follow is you shouldn't balance elements below until everything above it is balanced. So if you look first, Zn's fine. 1, 1, that's even. I can go to the next one. So now what I have is 2 hydrogens on the left, on the right, 1 on the left. So in order to make that even, if I put a 2 in front of the HCl, yes, that will change the hydrogen to 2, but just like in math, this is going to multiply to both. So that also makes my chlorine a 2, and then I'm balanced. You do not put anything on these lines. It's a 1. A 1 is understood. You do not write it. So to balance this equation, all I had to do was add a 2, a coefficient, in front of the HCl. That made my zincs even, my hydrogens even, and my chlorines even. So I'm going to move on to the next one. I see that I have Na, H, and O. Left side, I have 1 Na, 2 H's, 1 O. Right side, I have 1 Na, 1 O, and notice I have a hydrogen here and here. You add them. the total number of hydrogens on the product side. So I have 2 here because of the subscript, 1 there for a total of 3. So now I just start, my sodium's already balanced, so I go to the next one. I see I have 3 hydrogens over here, 2 over here. I have to fix that. So this is where it becomes guess and check. So if I were to just guess and put a 2 here, what that's going to do is make my hydrogens, now you got to add, remember, 2 times 2 is 4, plus 1 over there. You can't forget about that one. That would make my hydrogens 5. And here's why that's not going to work. And this is kind of where your guess and check and logic has to go. If this is 5, it is impossible to make this side be 5 H's. Because no matter what coefficient I put here, it's going to be multiplied by that subscript of 2. So what I have to do is I'm going to be like, oh, that's not going to work. I have to back myself up a little bit. Now let's say you didn't write that and you just kind of did that logically in your head. That's probably the best method. But you also want to balance with a pencil in case you do have to go back. So let's say, okay, balancing the H's like that didn't work. Well, let's try to put in a number here. Now that will make, that's going to affect a lot of things. Remember, so it goes through. It's going to make my NAs 2. It's going to make my O's 2. And now it's going to make my H's 2 here plus 2 here. It's going to make that 4. Well, this looks promising because I know I can make the left side 4. Remember, you don't want to go on until the ones before it are balanced. So now I got to go back up to my NAs. 2 on the right, 1 on the left. But if I simply put a 2 here, that's only going to affect the sodium, not the other ones. Now I move on to my H. If I put a 2 here, that's going to give me 2 times 2, 4. And then actually, it's going to fix the oxygens to be 2 as well, and now I'm balanced. When you do that thing in order, when you don't move on to the one before it is balanced, you're going to see a lot of times they just kind of fall into place. All right, the next one, I'm going to do Si, H, and O. Left side has 1, 3, and 2. Right side has 1, 2, and 3. Remember, oxygens, you add them. 2 here, 1 here. So we go on. SIs are good, H's are not. Now here's another thing that you're going to see, a little technique. This is called an even-odd situation. So what I want you to notice is this H on this side has a subscript of 3. This has a subscript of 2. That means no matter what I put in front of here, it's going to be multiplied by 3. And no matter what I put in front of here, it's going to be multiplied by 2. If I want to make these H's even, I can just continually guess and just keep adding numbers and numbers. But what I can logically think is, well, if I need to make something that's going to be multiplied by 3 and something that's going to be multiplied by 2 even, I can use our old friend, the least common multiple. And I know the least common multiple between 3 and 2 is 6. So on the left side, if I put a 2 here, that makes the H's 6. But again, it's going to make my SI's 2. And then I put a 3 here. That is going to make my H's 6. And that is going to make my O's, now remember you got to add 3 here and 2 here. That's going to make my O's actually 5. Got to go back and fix the SI. I put a 2 here. That makes my SI 2, but that changes my O's once again. I have 4 here now and 3 here for a total of 7. So this is a very special case. Right now, everything is balanced except those O's. And the problem is, this is 7. I can't really make this 7 because it's going to be multiplied by 2. So this is I would consider this a hard balancing problem. There's a couple ways you can do this. You can go back all the way to the beginning and say, you know, the common multiple of 3 and 2 being 6 doesn't work. Let's try the next common multiple and see if that works. Or you can do another technique where you use a fraction. So what you're going to say is, okay, I need to make this side 7. Well, if I'm going to multiply by the 2, 1/2 of 7 is going to give you 3.5. You can't really leave that fraction. So, but this is going to help. Don't erase anything. Don't change anything. If I know I have to get rid of this 3.5, what I can do is multiply it by 2. Because remember, 0.5 is a half. If I want to get rid of a half, I multiply by the reciprocal. So all I'm going to do is take 3.5 and multiply that by 2. And I'm going to get 7 here. What you do to one, you have to do to the other. And there's actually my subscripts. I just multiplied them by 2. So that I would consider a hard one. That's something you would have to kind of really work at. You could just keep going back and trying and trying and trying, but that is a technique with using the fractions. So now we're going to look at number 16. We did 15 on the previous page. So we have Fe, and we have O. Left side you have 1 iron, 2 oxygen. Right side 2 iron, 3 oxygen. I want you to notice you have a even odd situation here. No matter what you put here, it's going to be multiplied by 3. No matter what you put here, it's going to be multiplied by 2. So we're going to break the rules a little bit, and we're actually going to fix the oxygens first. So again, least common multiple between 3 and 2 is 6. So if I put a 2 here, that makes the oxygen 6, makes the irons 4. I put a 3 here, 6, and then 4. So in that case, again, we broke the rules a little bit. Just makes more sense when you're doing the even odd. I want you to notice the coefficients are still in their simplest ratio. It's a 4 to 3 to 2. This 3 is a prime number. That makes it its simplest ratio. I left 15 up here because I wanted you to see there is a big difference between the difficulty. I will not give you all number 15s and make you do every single hard balancing. Some of them are as easy as 16. So if you're really good and quick at 16 and you have to work a little bit about 15, that's okay. Just keep practicing. One more here. We have Si, O, H, and F. Left side we have 1, 2, 1, 1. 1, 4. Make sure you're paying attention to the order. 2 and 1. So again, the SIs are balanced. Go on to the next one. We need 2 oxygens here. So I put a 2. Notice that my counts always start from 0. That's one thing some kids make a mistake with. Just because I started with 1, I'm not adding 2 to 1 to make 3. Whenever you add a coefficient, you literally cross out your counts and you start from 0. So I have 2 oxygens, but that's also going to make my hydrogens 4. Okay, silicons are balanced, oxygens are balanced. Go on to my hydrogen. The only way to make hydrogen 4 is to put a 4 there. And then magically, it goes as in its balanced. If you follow that rule where you're going to go in order most of the time, it's going to go ahead and work out like that. Again, you don't put anything in the blanks. You do not put the ones in the blanks.